everyone. In the next session of Urban and Suburban Transportation Concept, Strategy and Organization. Today our topic is about that how we can schedule the public transportation. In this session, we will try to understand that how we can provide the facilitation in terms of information to any individual traveler. For that instance, as a planner, we need to minimize his fare and also to utilize the available resources at the maximum level so that we can plan and run the public transportation economically and financially viable. In this specific section, we will try to understand that what are the different components which are playing its essential role for the scheduling of the public transportation. Those are the four different components which play its important role. The first one is about trap building, the second one is block, while third one is run cutting, and in the fourth one is rotating duty rosters. We will try to understand each and every component with the example. While starting from the trap building, uh, in the trip building, we would like to compute the necessary headways because if so, maybe some of you already understand what is headway, but for those who did not understand what is headway, so headway is actually the amount of time between one vehicle, transit, bus, train, or tram, its departure and the arrival of the another one on the same station. This is called headway. Okay, well, while the second definition is about cycle time. Of course, we would like to compute the travel time along with terminal time along with the cycle time as well. So cycle time is actually the number of minutes needed to make a round trip from origin to destination and again from destination to origin. So that is called the cycle time, which should include the layover, recovery time, delay time, and so on. And the third one is about the terminal time. Of course, we would like to compute the departure and arrival time as well the purpose for the purpose to create the timetable. This is so if we have all those information such as headway, cycle time, and terminal time, we can create the timetable for any specific route for any specific transit route. So the terminal time is the time where a transit, bus, trains, etc. spend at a scheduled stop without moving. So usually this time is assigned. Some of the waiting time is assigned for the alighting and boarding of the passenger, but this terminal time is the time. So if there is a headway of a 20 minute, so the same train cannot leave before the assigned headway time. So in the same meanwhile, that specific transit mode will stay without moving at the same station. So this is called the terminal time. Now we are trying to understand the trip building with the example. As you can see here, we have the origin A and origin B. So the total distance between those two lines is we can cover it within 21 minutes. And according to the assumption to understand that problem in a more detailed way, so we should consider a certain recovery time as well. OK, because recovery time is assigned if there is a kind of a failure in the locomotive, in the engine, or if the tire is burst out or puncture out, etc. And we have the total headway of 20 minutes. Now we are trying to build the same trip and assign the timetable. Have a look. So as you can see here, we have delay recovery time of 15 minutes, and from A to B, we can reach within 21 minutes. So that means that the travel time is A to B and B to A, 21 plus 21, which is 42 minutes. Okay, and we have the delay recovery time of 15%. So 15% multiplied by 42 minutes, which is equal to 6.3. Of course, percent, so 15 divided by 100 multiply 42, which is equal to 6.3. And if we add 42 with that delay recovery time, so we have the total cycle time of a 48.3 minutes, somehow 48 minutes or 49 minutes. So that means that from A to B and B to A, we can complete that cycle within 49 minutes. Okay. And we have the given headway of a 20 minute, so we cannot plan for 48 or for 49 minute, because if we have the headway of after every 20 minute, so 20, 40 and then 60, so we have the total time for that specific route is 60 minutes. If you can have a look, so the total time we have 60 minutes and total travel time we have 42 minutes. Okay, so 60 minus 42, that is called the terminal time. Terminal time means where the same vehicle stand at the same station without moving. Okay, and plus the same delay recovery time is also added here as well. For example, if train late, if the BRT, metro, bus, train, tram, transit, any type of a mode get delayed because of any action, because of certain failures, so we have the delay recovery time of a 6.3 minute in like both directions. Okay. So to compute that how many number of transit unit we actually needed to complete that headway, we have the cycle time, which is the 60 minute divided by headway, which is 20 minutes. So 60 by 20, we have 3 minutes. So that means that when the train or tram or transit departure from A, it arrive at B at 10:21, exactly after 21 minutes. When its departure from B, it arrives at A at 10:51. So this is a very typical, how you can call it, the idealistic time that exactly it will reach in within 21 minutes. So delay might cause. The second important component, we have the block building. In the block building, we would like to assign the trips to all the vehicle so that they can run the timetable according to the assigned transit unit to any specific or schedule network. So to assign the transit unit to all trips, which is already specified in the timetable, we will try to understand that. Okay, the first step, we have to compute all the departure time, which is required for the headway for the terminal. So now you need to understand, one is the time which we want that the same train should move or serve on any specific network. But now we are trying to understand that what will happen if any train or any transit unit will go out first from the depot, and then it reach to the station A, and then it start function. So now we are trying to understand that depot time as well. So we have the operating time between 10 to 3 p.m. and we have the total headway of 20 minutes, and of course the same condition. Now we are trying to understand. Look, travel time from A to B, we have 21 minutes, and we have the terminal time, which is called, which were 18 minutes. Okay, so we have the time as well. So now we are trying to understand the block building, and we are also trying to understand that how the same block building can be created and to assign the timetable for the people information. Is before to go in a detail, we have 3 trains, which were like number of transit unit were like required 3, and the system start it function from exactly from 10 from one direction from A and the another direction from the B. So have a look. If the same service start exactly at 10 from A and at 10 from the B, but if we have the depot near to station B and we don't have the depot near to the station A, What we will do, we will start like it will take 21 minutes and then 5 minutes, 21 plus 5, 26 minutes. So if the same operating time is start from 10, so we need to start that train 26 minutes before to reach to A. So means if it start from 10, we will start our services from somehow 9:20. Have a look. As you can see here, or it start from our depot at 9:25. It reached to the B at 9:30, but it should start from A at 10. So of course it will need 21 minutes to reach from B to A, and then it will start its services from 10. As you can see here, as we already mentioned again and again, the headway. So the headway between each and every train is 20 minutes. So like it start from 10, another one will start from 10:20 and then 10:40. Similarly, 12, 12:20, 12:40, and so on. And so now to understand the trip building and block building, now we are trying to assign the timetable. OK, so this is called timetable. Now, to understand timetable a bit more in a detail, a timetable is actually a document where we set out all the information which is required to assess the passenger with to plan their trip. OK, so typically the timetable is the list where the services will operate in at which network. It also shows a particular location of each and every network stop and any particular stop. It is usually displayed in the form of a poster. It's sometimes also available in different cities and countries through the electronic format as well from the online URL source as well. The next point is about run cutting. Run cutting is actually to cut the block into the working days. OK, from here, starting from the trap till the block. So this was all the information to create the timetable. OK, and display the timetable. Now we displayed the timetable on every station. Now in the last 2 points, we will assign the same timetable to individual crew, to the individual driver, so that they can provide and operate the same functions in operation. As you can see here, if the same train starts from at 4 and then it services or finish it exactly at 24 or at 12 p.m. in the night. And then second one will start, train 2 will start at 4 and then its services functions or finish at 8 and then similarly at 8 and then 04. What we will do, we will do the run cutting procedure to assign the same timetable for train 1 to all the crew individually, similarly for the train 2 and similarly for the train 3. As we already mentioned, if our services are start from 10, so we will start our work from exactly from 9:30 or 9:25, so that to work all those things, all those operations successfully. So in the working duties, you need to understand that for the we have the maximum working hour, which sometimes in like some countries it's like 8 hours with 1 hour break. So again, it's depend, and then we have the train preparation time. OK, so before it leave the department, which should be 20 minutes, where they should check each and everything. When the train will arrive after the services, again, we need 10 minutes to receive the train. And then we need 15 to 10 minutes for the preparation of the same driver. OK, and similarly and so on. As you can see here, if we would like to follow the duty flow path for the train number 1, of course, where the services will start at 4, so their all operations will start at 4, and similarly till the ending of the termination. But keep in mind, if we need to reach to any specific location, so we can add that 15 to 20 or like 30-minute cycle time, so that it can reach to like that specific location if the same depot is not near to that specific location. The last point is about the run cutting. Okay, so we have the mm, yeah, almost each and everything. Now we are trying to understand. Now we are trying to split those driver and how we can assign the task to individual vehicles. As you can see here, we have the typical similarity among all those lines. So for example, if we start from duty flow of the path one, so the train start at number one, it and ends at number three. Okay, here is you can see here. So we will try to understand the most common hour. The first thing we need to understand the train number one have the total working hour of 24 hours. So if we have the 8 hour maximum time, so means that 24 divided by 8, 24 total operating hour divided by 8. Now I can see that how many drivers I do need. So in that specific situation, we need three to assign the task to the three drivers. Similarly for the train number two and similarly for the train number three. But here we have a one very common thing. So among the train number one, two, three, if there is a any specific common location, what we can do, we can share the same ride among those two drivers. So rotating duty roster. So the development of the duty sequence for the driver to assign the same timetable to the driver so that they can operate those services within any assigned network. That is the main function of the rotating duty rosters. We are trying to understand that can we assign the one duty roster for all the employee? Okay. So each employee should do all the duties and all employee work on the same working time. So this should be our because if we will plan, if we have the kind of a confined rules that this driver is on leave and etc. of course you can do that, but for any specific, for example, if we have 24 hour and if we needed three driver, so it's not possible to do the duty roasting with the two drivers. Number first thing is we need to choose the roster structure and then create duty sequence and then include those duties and develop sequence so that they can also rotate the okay. If someone is working from Monday to Friday in the early morning time starting from 4, so that doesn't mean that you should continue his work throughout the whole month or throughout the whole year. So that should be again change in like next week or like next month, according to that city structure and duty roasting structure and rules and regulation. So that means that we need to choose roster structure where each and every driver should work in the morning time. Similarly, in the afternoon, similarly at the night. So there should be no favoritism. That doesn't mean that if someone is living near to like that station, he should work in like the late hours. If someone want to do it and if it's technically possible, then it's fine. But there should be no boundaries that I don't want to work in the early morning. No, no. If it's a job, you have to do it. And then we need to understand the cycle basis group where the sequence of duties and days off should work together. For example, if we have the cycle base of the working group for 8 days, and then we have the 2 days off and 6 days working. So as you can see here, driver one, driver two, driver three, and so on. So this is just a typical duty roster structure. Okay, you can have a look. For example, if it's a staff number one or like Monday, he will work it like that specific time and then Tuesday and then Thursday and then Friday and like so on. Okay, because the continuity and similarity is quite important. So that will be easy for him to understand as well. This is how we can create the duty sequence from Monday to Friday, and then on the Saturday and Sunday. Okay. So those are the duties which we include in the for the developed sequence.